Okay, good afternoon, everybody. Thank you for coming for our session. My name is Avi. I'm the lead program manager for the credential management team in Windows Security. With me is Chris Corio, who's a program manager for user account control, or UAC. And he's going to come up later on to talk about and demo our UAC in Windows Vista. So what are we going to talk about today? First of all, we have a lot of content to cover. We're going to start by a high-level overview of the major components from the security platform point of view that we have in Windows Vista. We're going to cover isolated desktop, or what we call session 0. Kernel mode driver signing, big thing in Windows Vista, especially in 64-bit platforms. Crypto next generation, or what we call CNG, which is replacing basically the new crypto subsystem in Windows. The newly created smart card subsystem in Windows, or the re-architected smart card platform in Windows. We're going to go over the new architecture of WinLogon, and of course, user account control. So really from really high level, we can layer the operating system in terms of security to three main layers. We have what we call the secure operating system, which is a secure startup, isolated desktop, or session 0 that we're going to talk about later on, kernel mode code signing. On the interim, we have basically our crypto subsystem, crypto API, and the crypto next generation, and our CMS layer, or our X509 processing layer. On higher level, we have four main pillars: the authentication, authorization, audit, and credential management. Of course, we're not going to cover everything, but we're going to focus on the new features and enhancements that we really believe that are critical for driver developers, for hardware developers to understand before or when developing software for Vista. So we'll start with the bottom layer with secure operating system, and especially with the what we call services session, or the isolated desktop. So in Windows XP, we have the notion of sessions, and basically session 0 is the first session that logs onto the machine. If we are joined to a domain, then it's the only session that we'll have on the machine. And if we are working in a home user or a fast user switching mode, then we will have basically a session 0, which is the first user that logged onto a machine. And in a home scenario, we'll have additional sessions for each user that logs onto the machine. What you can see here is that in session 0, both services and applications are loaded to the same session. So the first time I log into a machine as a home user, both the anti-services and my application will be loaded into the same session. Other users will just have their application loaded in their session. Now, what that introduces is a problem in the sense that basically our services, which are pretty much the component that every hacker would like to attack first, as basically this is one of the components with most privileges in the OS, lives in the same session as the user applications. What that means is that Windows messaging attacks become much easier for hackers. So what we've done in Vista is we've actually separated session 0 from the actual user's session. So session 0 now have only anti-services. No user applications can actually run in session 0. So when we log into a Vista, which is joined to a domain, we will have two sessions by default. We have the session 0, which have the just services, no applications. And we have the rest of the sessions, which have the only applications. So this way we actually better protect anti-services from Windows messaging attacks. Chris is going to show you later on how UAC basically uses the secure desktop. So separation of services from user session. So as I mentioned, the desktop is a security boundary, and we would like to keep it like that. Right? So if there is anything vulnerable, such as services, we'll like to put them in session 0. Currently, if we have, for example, HSM that prompts UI in session 0, or just printer driver that prompts UI in session 0, the end user will not see it. Right? It's a completely different desktop. It's a completely different session. So what we have in Vista is something we call interactive services detection service, which is actually just a service that will show a dialogue to the user. Yeah, I'm sorry, the marketing guys could not find a better name for that. But it's actually a dialogue that the user sees and tell them, look, there is some service that tries to interact with you, and this service does not live on your desktop. So I can actually switch to session 0 and actually see only that dialogue. So my entire desktop actually disappears, and I will see only that specific dialogue that I need to interact with. So this way we basically better protect whatever information this dialogue gathers, whether it's credentials, whether it's pins to access HSM, or anything like that. So this is something that we will have only in Vista. Post-Vista, this is something that's going to be deprecated. And the reason is that we do have alternate solutions, and we really would like to, we would really like hardware vendors to start moving to a different programming model around how do you interact with the user if you are running a system service. So the way that we do it is, first of all, we should never, and that's something we've been preaching for a long time, services should never show UI, right? That's how attackers attack services, by attacking Windows messaging. So do not show UI if you're running as a system service. What you should use in the new services session architecture is if you just want to show a message to the user, tell him, I don't know, something failed or do something, then you can use WS send message, and that will just, to the interactive user desktop, and that will just show the UI on the user desktop. If you really want to interact with the user, you can create process as user and basically inject a process to the active user session and basically interact with the user that way. It's a little more work, but we believe it helps us secure the OS much more than it currently is. Kernel signing. So Windows Vista introduces mandatory code signing for 64-bit platforms. Now, we believe it is mandatory and required so we can have what we call an identifiable kernel state. We know exactly what binaries are loaded to the kernel. It can help us basically reduce platform vulnerabilities from unknown binaries that are loaded into the kernel. Now, the fact that we have an identifiable kernel state helps us to enable new scenarios. And I think that the one that may be the most popular right now is what we call next generation premium content. So think about high definition DVDs, think about high definition content basically that goes into the system. And for example, in our case, in the Microsoft case, the high definition DVD content will not play unless the entire kernel is signed. Other things is that basically identifiable kernel state helps us with is to address the growing threat of rootkits, right? So we basically, it doesn't completely prevent it, but it helps us to at least to identify or to leave it to the user to decide whether or not I want to install this rootkit on my machine, right? And there are a couple examples for actually signed rootkits that users can opt in to sign right now. So the feature for the code signing is called code integrity. That's the feature name in Vista, and that it's integrated into the kernel and into WinLoad. As I mentioned, on x64, all binaries have to be signed before the kernel actually loads them. On 32-bit, then the user will, or the admin will have the opportunity to decide whether or not it wants to load the OS if there are unsigned binaries on the OS. So as I mentioned, in terms of premium content, then if I'm trying to run, for example, HD DVD on a 32-bit machine, it won't run unless the entire platform is signed, or the entire kernel binaries are signed. And that's actually going to be up to the content vendor to decide what level of protection the platform should have for its content to be available. So we decided in terms of HD DVD that we require the entire platform to be signed. Other vendors might decide that it's not required for them, and it's okay that not all platform components are signed. In terms of developers, then there are a couple of things that can help developers develop kernel mode binaries on Vista. So first and foremost, we can use the kernel debugger. Second option is to use F8 and advanced boot options to basically disable the binary check when we load in the OS. Boot configuration can be optimized as well. Basically, a BSD edit is your friend. Right? There are options there to disable the integrity checks during load, and if you're doing testing for those components, that you can basically configure the boot to use self-signed certificates to load in your binaries. Again, that's only for testing purposes. But it's all configurable through BSC to edit. In terms of WCL and signing, then embedded signing is required for those kernel mode binaries. And the reason is very simple, right? It's for performance reasons. When the signature is embedded in the binary itself, the boot process is much faster, unlike the catalog signing, which is the other option that we have to actually sign binaries. In terms of WCL, then embedded signing is required before sending it to WCL, unlike other binaries that might suffice with, that basically catalog signing might suffice for. In terms of the kernel mode binaries, it has to be embedded signed. Now, this is not really a new WCL logo requirement, but it's more of just a clarification in the existing WCL requirements. Next, CNG, so crypto next generation. So basically, when we got to Vista, we started to get requirements from multiple either companies, governments across the world, basically with the requirement to use new types of algorithms. Unlike the standards one that we know today around RSA or SHAs, we started to get new requirements for new types of algorithms, such as elliptic curve cryptography, such as advanced hashing algorithms, such as SHA-2, and so on. Now, the crypto API platform that we have was not designed or in mind to handle these types of algorithms. There were a lot of assumptions built into the code, and we thought that this is the right time for us, or the right opportunity, to have a new crypto subsystem, which is much more agile and much more suitable for the new cryptography world of today. So a lot of the requirements were around better pluggability model, or the requirement to easily plug in new algorithms. Some customers that we know, especially again around federal bodies and governments, would like to write their own crypto algorithms and just plug them in. And today, crypto API, which is the existing cryptography subsystem that we have, is not always suitable for it. So new crypto algorithms can be plugged in relatively easily, either from the native protocol or the primitive algorithm point of view, or from the protocol point of view. So as I mentioned, crypto agility is one of the things. It's much easier to plug in asymmetric algorithms, symmetric algorithms, hashing algorithms, random number generators, things that really are not available in crypto API. As I mentioned, we support a new set of algorithms, what we call Suite B class algorithms, such as elliptic curve cryptography. By default, we provided the system out of the box, what we call ECDH and ECDSA, Diffie-Hellman and digital signature algorithms. In addition, we are working, of course, against common criteria requirements. So we have what we call private key isolation, making sure that private key is always executed within the LSA, within the protected process of the operating system. And yes, we have improved significantly cryptography performance with this new platform. So just to give you a high-level overview of the new architecture of CNG, then let's start with the green boxes. So these are actually the pluggable components that we have in the OS, or the classes of pluggable components that we have in the OS. So we're talking about symmetric cryptography, hashing routers, asymmetric signatures, key exchange, random number generated, and key storage routers. For those of you who manufacture either smart cards or HSMs, hardware security modules, then key storage router is what should interest you. That's actually the pluggability point for integrating in either HSMs or any hardware module that stores cryptography-related information. Primitive providers are basically the actual implementations of all of those routers. So we can talk about ECDH, ECDSA, we can talk about symmetric algorithms, and so on. Protocol providers basically use those routers. So if, for example, SSL-TLS would like to use ECDSA, then it will use one of the asymmetric crypto routers to see what actual algorithms are on the system and use them. So this is a high-level overview of the new cryptography subsystem in Windows. In Vista, both subsystems, Crypto API and CNG, will live side by side. So if you have applications which are based on Crypto API, they will still work. just fine. But moving into the future, sometime post-Longhorn, crypto API will be deprecated. So if you are working now on new applications, on new devices that require cryptography, then I would recommend using the CNG platform as the platform for development and not crypto API. Move to the upper layer. So we're talking about authentication and lifecycle management of the OS, credentials. So WinLogon. WinLogon architecture in XP looked pretty much like that. We had session 0 that actually had loaded the entire user profile, contacted the LSA, talked to the service control manager, talked to the shell. And the way that we put it is that WinLogon was kind of the trash basket for everything that needs to happen during logon, right? In XP, when you hear the login sound, that's an event that's fired from WinLogon. Using user profile, that's something that happens in WinLogon. Applying group policies, that's something that happens in WinLogon. So in Vista, we decided to re-architect it to basically make it easier for developers to develop for and to clean the OS architecture in a way. So the new architecture in Windows Vista, again, we have the session 0 and the other sessions, again, in line with the session 0 isolation or the isolated desktop that I mentioned earlier. So we have a new service that loads only in session 0, which is called WinInit. And this service actually interacts and boots the OS in terms of user profiles, group policies required for the machine, interacts with the service control manager, and so on. The WinLogon process was cleaned up. And this is loaded only in the user session. And this is the component that's actually responsible for interacting with the logon UI that we have in Vista, with the different credential providers that I'm going to talk about in a second, and with the LSA to perform the actual login and authentication operation. So I think that the key thing in the WinLogon architecture is to understand the credential provider concept. So if you have ever developed GINA or the authentication dialog that we have in XP or previous to XP, then this was basically the integration point of vendors into the login process of Windows. This was not something that was easy to write or easy to develop. And now in Windows Vista, we're basically replacing the concept of GINAs with the new credential provider concept. So if any of you has GINAs, they do not work on Vista. The GINA concept is completely deprecated in Vista and is replaced by the new credential provider and login UI concepts. So as I mentioned, credential provider replaced GINA, and they are the plugin model for the UI. So we basically can interact with one or more credential providers. For example, we have a password credential provider that knows how to show us the username and the password on the login UI. We have the smart card credential provider that shows us only the PIN text box for the smart card. And we can plug in our own credential providers, for example, to be used with to perform biometric authentication, OTP, and other types of devices. The only thing, and that's maybe the big difference between what he had in XP and Vista, is that in XP we could replace the login UI completely. Basically, the GINA infrastructure or the GINA SDK allowed us to completely replace the login UI and put whatever logos we wanted, whatever colors we wanted, whatever controls we wanted. We had full control of it. In Windows Vista, this cannot be done anymore. And you can only replace a subset of the controls on the screen itself. And the reason for that is actually pretty good. We've done a lot of research and got a lot of customer feedback that the actual GINA development is too complex. And most vendors really do not need that level of interaction with the OS and that level of flexibility changing OS components. So what we actually done is provided a very easy-to-use COM interface, and that is the actual credential provider interface, a very simple set of COM interfaces that can be implemented. Through the implementation, basically you can modify controls in your credential provider. So for example, I can decide which labels will be displayed, which text boxes, which controls, which images. So for example, if I'm a developer of a biometric credential provider, then I can say, okay, so don't put any text boxes. The only thing I want to show on the UI or on the login UI is just an image with some thumbprint image on it and a text saying, please put your finger on the reader, and that's it. So the interaction with the login UI is much simpler than it was in Gina. We still have a various range of flexibility on how to interact with it, but again, it is limited than it used to, more limited than the XP Gina concept. So just to give you an example on how, for example, the password credential provider works. So the user clicks Ctrl-Alt-Delete, WinLogon intercepts this event. Now we need to request a credential from the user. So the login UI enumerates all the credential providers that are available on the system. So in our case, we have 3 credential providers. And now if I'm a user, I will see 3 credential providers on the screen. So I might see the password one, I might see a smart card one, and I might see an OTP or a biometric credential provider. I click one of them, for example, the password, and then the credential provider actually renders the UI for the user. I have the username and the password text boxes. The user then types the credentials, click OK. What happens next is that the actual login UI talks to that credential provider and tells it, OK, please give me the credentials that you gathered. The credential provider can do whatever you want with it, return it back to login UI, which in turn returns it to WinLogon, which actually talks to the LSA to perform the actual login operation. So now take this diagram and replace the credential provider with whatever you want. Again, the interaction is much simpler in terms of development. In the Gina world, as a developer, we had to actually interact with the LSA to perform the actual authentication or login operation. In Vista, all I need to do is just to gather or harvest the credentials from the user, and that's it. Login UI and WinLogon will take care of the rest. They'll interact with the LSA, they'll interact with the shell itself. So from a developer point of view, the experience is much, much better. The smart card subsystem. So this is the current smart card subsystem in XP and below. So basically, we have the smart card resource manager that actually interacts with the readers and with the cards themselves. On the top, we have the CAPI, or the crypto API. And in the middle, we have the concept of CSP, or that actually the cryptography service provider that actually every vendor has to implement. Right? So every smart card or HSM vendor has to implement the entire CSP. And just to give you some context, to develop a full CSP is something that takes about a year to an experienced developer to create such a middleware. Now, in that smart card CSP, you'll usually have the PIN management, the dialog, the PIN dialog management, caching, basically all of the common crypto operations that need to happen when interacting with smart cards. Now, about a year and a half ago, we've done research with basically most of the big smart card vendors, and we found out that about 70% of the code in these CSPs is actually common. People are actually were rewriting this code over and over again for pretty much every smart card middleware. So, and just so you understand, this is pretty much one of the well, I won't say that, but this is one of the hardest components to write in the OS. You both need to interact with the user and with a hardware device. And in that case, we found that the experience from the development point of view, the stability of those components was extremely low. So what we've done is we actually decided to take this 70% code and write it ourselves. And that's what we call the base CSP. So now Microsoft actually ships something we call the base CSP that includes all of the common cryptography operations that need to happen to interact with a smart card. So we manage the we do PIN management, caching, common crypto operations, and the actual smart card vendor has to write only a relatively small piece of code, which is called card module or card mini driver. Depends on what marketing will decide by the time we ship this. That actually has only card-specific operations. Okay, it doesn't have to do any of those common operations anymore. So just for comparison's sake, to write a card module takes about a month in comparison to the year of development to develop a full CSP. So as you can see, it's a little more complex than just the base CSP and the card module. So I mentioned CNG and crypto next generation. So we in Microsoft already started to do some work around supporting CNG and algorithms other than RSA. So what we've done is we developed our own smart card base KSP which is pretty much, and as I mentioned, KSP is the router to work with devices, with hardware devices. So we developed what we call the smart card KSP that has the same characteristics as the base ESP, but it can support other card modules or other cards. So we can now support cards other than just simple RSA, which is pretty much 99% of the cards and tokens that we have out there today. And we can also support what we call the dual mode card modules. So we can support cards that has both RSA and ECC support on it. So as I mentioned, in terms of smart cards, so first of all, our goal was to simplify the development process for smart card vendors and for HSM vendors. So this model of base ESP, KSP, and card modules is already available today in Windows Update for down-level platforms. So we already support the new smart card architecture or subsystem from Windows 2000 up to XP, and of course in Vista and Longhorn server. Enhanced user experience. So one of our goals in the team around smart cards is to really make them a commodity, really make them something that every user at home can use. And for that, we had to go a long way. And part of it is we're introducing something similar to WICO, and we're going to actually allow vendors to submit their card modules for certification by Microsoft. There is a center that we've created not a while ago in Ireland that actually accepts card modules from vendors for certifications and uploads them to Windows Update, pending, of course, approval. The next step is to support plug and play for smart cards. So a smart card is not a native hardware device in Windows, right? It's not a reader, it's not a camera, it's not a printer. But we still want to have the same user, to give users the same user experience as they have when they're just plugging in their camera or printer. So we're going to support plug and play for smart cards as well. And the scenario that we have in mind is that governments across the world are now starting to go with what's called electronic identity or electronic or digital identity concept. And we have already countries such as Belgium, such as France, that already started to deploy millions of smart cards to the home users. And the scenario that we always have in mind is that the user can take his smart card, go back home, either stick it to the USB port or insert it into the card reader. Windows will recognize it, say, OK, I don't have the right card module. We'll go to Windows Update, download, install it, and boom, you're good to go. Zero software deployment for using smart cards. That's the level of experience that we're trying to achieve for smart cards today in Windows. Looking from a little different direction, we are trying to move into a model where there are no more passwords. Right? That's one of the objectives that I have on my team. We need to make Windows as easy to use with smart cards as it is today with passwords. Right? Make sure that all the scenarios work, that nothing is broken. Myself and basically the entire team is now working on smart card login only. We don't have passwords anymore in Microsoft. And the goal in Microsoft is to move to only smart cards for the entire Microsoft employees, which is about 70,000 within a year from now. So to enable that, there are two major broken scenarios that we actually fixed in Vista. So one of them is the actual ability to join a machine to a domain without using a password. Right? Today, I cannot do it. I don't have this common root of trust between my domain controller and my non-domain joined machine. So what we're doing in Vista is we're actually propagating the root certificate of my domain to my smart card. So when I actually come to join a machine to a domain, I have this common root of trust. I trust the domain controller root certificate. So this is one scenario that we fixed. Another scenario is unblock. So today, if I have password and I accidentally blocked my card, then nothing happened. I can just log into my machine, launch my IT department, unblock application, unblock my card, and I'm good to go. But what am I going to do if I don't have a password? And I can't log into my machine to launch the unblock applications to unblock my card. So what do I do now? So one of the things that we've done is we actually integrated the unblock and pin change functionality into the Vista Logon UI. So now I can actually unblock my card even before logging into the OS. The way that we've implemented is using credential providers. Right? So some of the UI is just a pin, and some of the UI is the actual challenge response that we are using to unblock cards. Service hardening. So services will always be the #1 component in the OS that hackers will try to attack. Right? it's a service that runs, it's a component that runs usually without without user interaction. I usually won't see it. It usually has very high privileges, right? Most services that I know of run usually with system or local system privileges, right? And as we can see, most of the biggest worms and viruses in the past, in near past, actually attacked services, right? We're talking about Sasser, Blaster, CodeRed, Slammer, and Nimda, of those actual worms. So what we're basically advocating developers to do is start moving to much least privileged accounts, right? Start moving to local service or network service accounts, right? Most services really do not need to run as local system. We have a new concept of services, right? So we can define whether our service has restricted or unrestricted access to objects within the process. So this is something I can define now when I write my services. So even if my service was hacked, my OS will still not be compromised. Service seeds and write restricted tokens. Again, we can decide that my service can do whatever you want, but it cannot write to any vulnerable system resources. And of course, we have now the ability to supply network firewall rules. So let's say that I have a service that listens to some ports, but let's say I want to decide that my service listens only to TCP ports and not to UDP or any other ports. So now I can define it when I write my service. So when my service loads, it actually automatically configures Windows Firewall to listen only to subset of the ports and or only incoming ports and not outgoing ports and so on. So this is very powerful and very granular ability to define how services operate in Windows OS now. I would like to invite Chris to talk to us about UAC and give us some demos. Here you go.
Now so yeah. One of the major things we did in Vista was we really tried to drive home the message that, the admin, the running every system as admin, and probably all of you on XP right now run as admin, was unnecessary and something we really wanted to drive out of the operating system. We really wanted to make the standard user the default user, and the level that applications ran at. There's no reason that an LOB app or most enterprises shouldn't be able to achieve that level. And what we wanted to do was we wanted to both address the issues we saw in Vista, and then afterwards address and help the industry with legacy applications and ensure they weren't broken, and do our best to fix and provide guidance for our developers. So user account control, like I said, all users by default run as a standard user. And I'm going to show you kind of what our new logon experience looks like in the next couple of slides. But basically, if you're an admin, a member of the administrators group, when you log on to Windows Vista, we will create a filtered token, one that looks just like a standard user, and create your interactive session with that token. So by default, everything you run, everything within that session will be run as a standard user. So the next thing is there's obviously cases where you're going to need to run with admin privileges. Say, a control panel applet that you have to change some settings, something, some machine-wide configuration of an app and so on. So in those cases, we provide an elevation path. And I'll show you this later during the demos. But basically, you'll click on a shield, and the shield icon will be next to the link or on the button, or however we start. And the next thing you'll see is a consent dialog if you're an admin, or a credential dialog to enter the credentials of an admin if you're a standard user. You can imagine when we first started running this, we were seeing failure rates of 50% on our apps. They were not running well as standard user. So we've done a lot of work to mitigate that with a feature called data redirection. And basically what that is if you're a developer, your application is running in program files, you create your log file. Of course, you didn't specify a path, so it's created right back in program files. If I was running as an admin, if I was running on XP, this wouldn't generate an error. And now in Vista, when I'm running as a standard user, that write would fail. If you were to write that log file, it would fail. So what we've done is we basically take places on the disk, such as program files, Windows System 32, other directories nested beneath Windows, and we'll redirect those writes to a virtual store in the user's profile. So basically, an application's writing, it has no idea that the write actually would have failed as a standard user, and it continues running with no problem. The other thing we did is we implemented a feature called installer detection. And a lot of applications, their name setup.exe, they write all their binaries to program files. I mean, almost every installation on a machine requires administrator privileges. So when we see something like that, or when we see an update with the file name being setup.exe, or the install MSN Messenger was one of the ones we've actually fixed that subsequently. But that was marked for elevation, and we knew that was an installer, and we prompt the user to run that. So, I mean, that's some of how we're progressing the Windows infrastructure to really move towards that standard user experience, to be a member of the users group rather than a full admin. So let's kind of talk about what happens right now in Vista when you log on. So Abby is our administrator user, and of course she enters in her credentials. So when she logs on, what we actually do is we perform 2 logons. The first one's with her full token, her full admin token. And we take that token and we sort of save it away back in LSA. And then the next thing we do is we actually filter that token and perform a second logon. So then she kind of has 2 tokens, right, within her context. And we take that standard user token and we create the desktop. So now we've created her desktop, and of course she can do the things that you would expect a standard user to be able to do. I guess in Vista we've added it so you can change the time zone, run common applications. I mean, obviously you would want to do that. Install network printer drivers, enabling key IT pro scenarios. I'll show you can change or at least part of changing the time zone. Now you can see the calendar. It was one of the big big things in XP that was always troubling. But yeah, so we've really worked through Windows and understood where do we need admin privileges, and where can we really offer a member of the users group a great experience on Windows. So there are cases, right, where you're going to need the full admin token. And again, those things like we talked about, changing time, something like Kerberos. Kerberos queues the security off the time. And then configuring a large-scale application like IIS, obviously they're going to have settings that you wouldn't want a standard user to tamper with. Any application that sort of implements a security policy is going to have a portion of it that needs to run as admin. And then, of course, installation, one of the biggest times where your system will need admin privileges. So basically what I'm going to do is I'm going to give you a little bit of guidance. This is something for you guys to bring back to your companies. And then after we finish that, I'm going to tempt the demo gods with a Vista demo, because what would a good presentation be without tempting them? So all right, for installation, our big message here is use MSI 3.1. MSI 3.1, we've integrated the consent and elevation experience directly into it. It allows you the facility to basically, upon an install, a standard user will be prompted. And more importantly, it actually allows you the ability to update your code. And MSI will do the elevation for you. So basically what you do is, when you would perform an install, you'd embed a certificate in that installation. And then later on, you would sign your patches, for the maintenance of your application with that cert, and MSI would do the update. This is going to be a huge benefit for your user's experience, for the user experience of your installs and updates, and it's something we absolutely recommend moving into the Vista timeframe. And as you test your applications, I'm sure you'll see where these things come out. Be careful where you have update. Where you have that update button in your app, or where you go out and check for updates, make sure you run that. Even go on to XP and run it as a standard user. I'd be curious if it works, and if it doesn't, you'll immediately know what you can address to fix it. And the last thing here is that we expect the number of standard user deployed apps to increase. Click Once is a great technology for deploying per user applications. You can actually do it with MSI as well, and there'll surely be documentation coming out describing how to do that. So all the patching stuff's already documented, already out on MSDN, ready for you guys to use. So we'll talk a little bit more about kind of some runtime suggestions and really kind of like where we're going with this initiative as a whole. A lot of applications did admin checks. They really when you're running your UIs, first thing, am I an admin, check token membership, always happen. these are going to fail in the future. Even if you are a member of the admins group, that filter token won't make it look like you are. So, I mean, that'll immediately fail. And really what we're going to do is we're going to encourage you to sort of, understand that when you're running as a standard user, you really have the user's identity and the ability to write to their profile. And when you go up to that admin code, at that point you're really, you have the ability to impact the system, but the user the user profile that you would manipulate might not be the one you intended. So that's kind of the message there. The message is when you elevate, don't mess with the user profile. The user profiles are going to start to become the user's identity and really how you manipulate the user's interaction with the machine. And of course, the last thing is user account control and code access security really allow our managed developers to take the next step and become, and really enhance their security. And we, of course, I can't imagine we wouldn't expand the marriage of these two features moving forward. But I mean, that's an excellent way for you to even understand the implications, that your application is doing and so on. It's definitely a good thing for managed developers to investigate. All right, demo time. So that's good. So okay, the very first thing I always like to show off actually is the time. I mean, if you're on XP, you're running a standard user. Actually, I always love doing this. So show of hands, who's running Windows XP as a standard user? Wow, this is the best crowd I've ever seen. Yeah. I'll be honest with you. Usually you get like 2, and they're like, oh, okay, thanks. But anyway, so yeah, if you guys run as a standard user, when you click the time, you get that error message. You can't even see the calendar, you're trying to do so. So on Vista, we've changed that. Obviously, immediately, right there, you notice. Click on it, you can see the time. What if I wanted to change it? So I click date and time, and check it out. There's your first shot at what the shield looks like. So shield basically says, this operation, this button is something that requires administrator privileges, and it's going to change the system. So, changing a time zone, I guess we can do that, and of course you see it. And it's really not an impact. It's per user setting now, and kind of just change how the time works. But all right, let's actually try to change the time. Cool. So what happened here? So this is the first time you guys are seeing elevation, and this is the beta 2, the one that we're releasing this week. So what you actually see there is session 0. This dialog box, this user account control dialog box, is completely isolated from any malware, and it's put on the secure desktop. What we actually do is we have an alpha blend of the desktop the user was just in, but this is completely in a separate desktop from any of the other processes the user is running. And of course, if I select continue, it will open the dialog and obviously allow me to change the time. So do that. Anyway, so all right, so that's the beginnings, and we'll kind of talk here for a second. I'll give you a bit of history and kind of show you how UAC is kind of moving. It's maturing as a feature pretty quickly. So let's kind of walk through and look at the December CTP build. So this is what the control panel looked like in the December CTP. We didn't have any of the shields around yet. We were just kind of introducing the shield into the user experience, really kind of getting people to get a feel for that and really understand what that meant. So kind of mundane. All right, so here we go. Here's the February CTP, and you're looking at the hardware and sound control panel. And then we really identified, all right, now we know everything on that window practically requires admin privileges. So we realized, okay, they probably don't all need that. So I'll show you now in the beta 2 build, the next version, where we're seeing that now. So the control panel, and of course that was hardware and sound. So you can see, like we've dramatically reduced the number of shields, and we really did our best to understand how the operating system was working for a standard user. And one more example, you can see the system and maintenance control panel again, just peppered with. I'll use Avi's favorite feature, if I can find where I am. Perfect. Oh, there we go. And of course, system maintenance. You can see right there again, we have one shield and beneath it, a couple more. So we're we're really doing our best to understand and really make that standard user experience great for our users. So the next thing I'm going to present to you is actually a feature and an application that we've just released this week. It's on download.microsoft.com, and it's a tool we call the Standard User Analyzer. And the Standard User Analyzer is basically an offering for ISVs and developers so that they can run this application, run their application on Vista, and watch where it would fail and watch where it does admin operations. This is really like us trying to drive and help the ISV understand the security context they're operating under. So I'm going to kick that off. And of course, we have a wonderful demo app, so I will go and get that. And there it is. And I'm going to launch it elevated. So what this is actually doing is it launches it as a full admin, filters the token, and then runs it as that filtered token to kind of see what's going on. Just kind of mimicking exactly like what the logon's like. So I'll launch it. And of course I'd allow it. All right. So here you can see, it's pretty much the tabs are an example of what a developer might do in their code. The first one is great. Any file operations you were to do, opening privilege files, system.ini. I just did a create file call on that. So it's like we're opening that privileged operation and we're doing those things. And registry virtualization. So like FileVirt, HKLM software will also be virtualized within the registry for the user. Again, to combat any app compat issues and so on. So I'm going to go in here, and I'll open this key, of course, with write privileges and so on. And my favorite one here is the check token for admin SIDs. Everyone loves doing this. Am I an admin? We fixed a lot of app compat issues where apps were failing because they did an admin check, and then as soon as we lied to them and told them they were actually admin, everything ran perfectly. So not uncommon. So okay, I basically run my application and it's going to exit. And I'll load up my standard user analyzer, and you can see now there's a fully populated log file. And of course, when I go to the file, you see I open this, and the API call I used was create file W. I have a stack trace for it. It's very helpful for the users. And the same goes for the registry. You can see immediately what your application was doing that required your admin privileges and moved you, would require you to change them to work on Vista. The last thing, my favorite one, check token membership. So that's a pretty good look at some of the stuff we're doing. And again, this is a standard user analyzer, and it'll be available on download.microsoft.com probably the end of this week, maybe early next. Any feedback you have, seriously, you can come up to me after this. I'll give you my business card, and you are welcome to send your feedback to me. This is something we're very serious about, and I would love to hear anything you have to say about it. So, all right. Kind of demo gods worked out?
You're with us here.
So the call to action, this is two things. The first one really echoes what Avi talked about with respect to, get your 64-bit drivers signed and really work to drive that home. If you have any questions about that, we're more than happy to help you with that. And the second one is, test your applications and understand how they work on Vista. Understand the difference UAC will make. This is more than likely, going to probably be somewhat traumatic if you guys haven't ever designed for the standard user.